So, rate of reaction. Let's talk about this as well. Rate of reaction changes during a reaction. So when you're reacting something, there is going to be a graph on this, like the slope, as you can see in the right side of this slide, this diagram. Most reactions are really, really fast in the start, so that's when the slope is the steepest. And over time, because reactants are getting used up, the reactants are reacting, they're going to slow down, slow down, slow down until it plateaus. It plateaus because there's no more reactants. Everything's reactant. It's over. That's it. So in a rate of reaction graph, you'll see that it's very, very steep in the beginning. In the initial rate of reaction, slows down and then plateaus. That's always going to be what it looks like. As the rate changes, we can measure the mean rate over time, and this is used by figuring out a tangent. The mean rate of reaction is just reactants used up or products formed. When you're reacting something, you're going to use up all of your reactants or you're going to form a certain product. So to figure out the rate of reaction is just products formed divided by time or reactants used up divided by time. So the units are usually grams per second, cm cubed per second, or mole per second. It really depends on what exactly is the reactant or product that you're measuring. So if it's like a mass, it's in grams. If it's volume, it's going to be centimeters cubed. But it's always going to be per second. The second is the standard unit you'll be using when you're measuring a rate of reaction. So as you see on the rate of reaction graph, you can draw a tangent to figure out the rate of reaction, because the slope, basically the gradient of the point, is the rate of reaction. And the way you figure out rate of reaction is change in y over change in x. And this is the typical, this is just the math equation, essentially. It's just change in y over change in x. And sometimes they will ask you to figure out the rate of reaction at a certain point. So at maybe like 20 seconds, figure out the rate of reaction. So at the point from 20 seconds, you draw a straight line, draw a triangle, and then figure out the rate of reaction just from that triangle. Change in y over change in x. The thing with rate of reaction, we have the collision theory, and the reason why anything reacts is because of your particles and these particles colliding with each other. It's very important that you understand that rate of reaction is because of these particles colliding and frequently colliding with the wall or colliding with each other. So the collision theory is essentially saying that the rate of reaction occurs from the successful collisions when reacting particles collide with each other and with sufficient energy. So it's how often they collide with each other and how much energy they collide with each other. And it has to be enough energy. The minimum amount of energy that the particles must have to react is called the activation energy. So anything below the activation energy is not going to react. This is why they talk about rate of reaction with particles. If the particles are not colliding with enough energy, it's not going to react. Increasing the concentration of reactants in solution is going to increase the frequency of collisions. Same thing with increasing pressure, and same thing with increasing the surface area. To understand this, increasing the concentration means there's more particles, more easily collide with each other. Pressure, again, you're going to be hitting the wall more often, more collisions, more rate of reaction. Same thing with surface area, more collisions. All of it's just increasing the collisions. Increasing temperature also increases the frequency of collisions, but it also increases the energy. So this is the one thing that differs it from just increasing the concentration or the pressure. Those things increase just the number and the frequency of collisions. Increasing the temperature also increases the energy of collisions. This in turn also increases the rate of reaction. Catalysts, which is something that you do need to know, it's a big part of chemistry and also biology, but chemistry. Catalyst increases the rate of reaction by providing an alternate pathway for the reaction that has a lower activation energy. So it doesn't directly lower the activation energy. It finds an alternate pathway that has a lower activation energy, and this allows for an increase of rate of reaction. Important to note that catalysts never get used up. So if you add a catalyst into it, it's just going to decrease the activation energy, increase rate of reaction without ever actually being used up. And you can see the little diagram on the side. You can see that the activation energy is a lot lower with a catalyst. It's a lot smaller. So I hope that was understandable. This is a lot of math for rate of reaction. I'm going to skip through some of this because you don't need to know too much detail on that. So here, it talks about we're just going to quickly talk about this. It's saying that the student changed the investigation in the very beginning. It talks about collecting 20 centimeters of gas to make sure that the time was greater. So they wanted a lower rate of reaction because they wanted more time taken to collect this gas. So what would the changes be? If you want a lower rate of reaction, you're going to have to do the opposite of what I just basically told you. So essentially using a lower temperature, using a higher temperature is going to increase it. So you want a lower temperature to decrease the rate of reaction for the time to be longer. Catalyst is going to increase it, so that's wrong. Larger conical flask isn't going to do anything, that's wrong. Smaller pieces of zinc means larger surface area. So that's also going to be wrong. So your only answer left is going to be use sulfuric acid of a lower concentration. That is the answer for this specific question. The rate of reaction questions are very heavily application. So it's just understanding that higher rate of reaction, what are the factors? What factors affect this? And then you'll be able to apply it. The last question we've earlier just talked about, hydrogen gas. What's the test for it? Burning splint, squeaky pop sound. Very straightforward. I saw that there was a question.